Scoot. Go.
I think they're more than
Okay, now. And now, see, now Daniel there doesn't have to try to look around your head. Okay, so we are just going to see some different ways how these diagrams can be set up, but we will still be finding proportional parts to each other and creating equations. So we have a couple of theorems to talk about, and these theorems are going to tell us what other type of proportions we can create. So the triangle proportionality theorem. The triangle proportionality theorem tells us if a line, if you guys are so inclined to have a conversation right now instead of paying attention, you will be split. Okay? Because this happens almost daily. If a line is parallel to one side of a triangle and it intersects the other two sides in two distinct points, then it separates these sides into segments of proportional lengths. So let's try to draw a diagram showing what this means. So here we have a triangle. Okay? And it says if we have a line that's parallel to one side of the triangle. So let's say I have this other line here, and then those two lines are parallel to each other. It separates this into proportional lengths. So what that means is, let's say that's 5, 10, x, and 12, is we can now make this proportional. So we can say 5 over 10 is equal to x over 12. And solve that. Okay? So if we have a triangle with sets of parallel lines, we now have this being proportional to each other as well. That's what the triangle proportionality theorem is telling us. The converse of the triangle proportionality theorem is if we know that we have these sides proportional. So if I were to fill instead of x here, if I were to fill in this as a 6, 5 over 10 is the same as 6 over 12. So if we know that they're proportional, then the lines are parallel. So it's really saying the same thing, just in the opposite order. So if a line intersects two sides of a triangle and it separates the sides up to proportional lengths, then the line is parallel to the third side. All right, so those two really go hand in hand with each other. If we have proportional lengths in a triangle like this, then the lines are parallel. If we know the lines are parallel, then we can set up proportions. And then we also have the mid-segment theorem. Okay, what do you think the word mid-segment is going to mean?
In the middle.
In the middle, right? It's going to have something to do with in the middle. So a mid-segment of a triangle, is parallel to one side of the triangle, and its length is half the length of that side. Okay, so mid-segment here, the mid-segment part means in the middle. Okay, so if we have a triangle, and if I draw the mid-segment, that's in the middle, that means that the two sides that it splits have to be even. So if this is 5, this length has to be 5. Over here, if this is also the mid-segment, if that's 6, that has to be 6. So what the mid-segment tells us is that this length, that mid-segment length, which is right here, is half of the other one. So if I tell you this length here is 14, half of 14 is 7, so that one's got to be 7. Okay? So it only happens if we have a mid-segment. And then we have a few corollaries which go with this first diagram. It just tells us if we have more than 2 parallel lines, so if we have 3 or 4 or 5 parallel lines, those are also cut off at proportional parts. Okay? So if we ever have more than just 2 parallel lines, those are also going to be proportional to one another. So we're going to try some examples with this. So once again, it's looking at the diagram, deciding which parts are proportional to each other, and setting that up correctly. 5. RT is 9 and WS is 6. We want to find out what RW is. So we're going to first want to label everything. So RL here is 5. R to T, that whole length is 9. And WS is 6. We want to find RW, so we can just label that with any variable we want to. So I'm going to label that with X. Looking at this diagram, what other length do we know? LT is 4. How do we know LT is 4? Yeah, 9 minus 5 is 4. Okay, so what proportion can I set up here to find my RW?
5 over 4.
Okay, so 5 over 4 should equal what? Good, X over 6. And now how would I solve this? 6 times 5, what's 6 times 5? 30 is equal to 4x. Divide by 4, so what's the value for x? Yes, it is a decimal. Yeah, 7.5. So my RW here is 7.5. Is that okay? All right, it's just setting up more proportions. Same diagram, but with some different values. So this time, on the diagram, we know TR is 8. So that whole length is 8. LR is 3. RW is 6, and we want to find WS. So this time I'll label WS as Y. So what other length do we know for sure? LT is 5. 8 minus 3 is 5. So how can I set this up as a proportion to find my Y?
3 over 5.
No, 3 over 5 would have to equal 6 over Y. Why does the 6 have to go on top? Yeah, it's corresponding with the 3. They're both on that top section. All right, so solve this. So how are we going to solve this? So 3y is equal to 30. Yeah. So WS then should equal 10. Is that okay? I mean, really, this whole chapter is about setting up proportions. We could see a few things that are slightly different. So here we have the same type of diagram. So in triangle RST, this time TR and VU are parallel. SV is 3, VR is 8, and UT is 12. We want to find SU. So probably go ahead and label first. So SV is 3, VR is 8, and UT is 12. We want to find SU. Use any variable you want. 8 over 3 equals what? 12 over x. Could you have set that up a different way? Yeah. Yeah, you could have certainly had 3 over 8 is equal to x over 12. It gives you the same thing. So then what does this end up equal, or how do we solve this?
36.
36 is equal to what? Yeah, 8x. So then what's your x value here? It is a decimal. 4.5. So 4.5 is our SU. Is this making sense? Okay. I got 2 more examples. In triangle DEF, DH is equal to 18, HE is 36, and DG is half of GF. We want to determine if these 2 lines are parallel. If the 2 lines are parallel, then the sides have to be proportional. So we're going to set up the proportion and see if they are indeed equal to each other. So start off by labeling. So DH is 18, HE is 36, and then DG here is half of GF, And then I guess we'll just label that side as GF because we're using it in the other one. So how would we set up this proportion?
18 over 36
Okay, 18 over 36 equals
1 half over
1/2 GF over GF. What happens to our GFs here? They're going to cancel. So now we need to know, does 18 over 36 equal 1/2?
Yeah.
Yes, it does. 18 over 36 is also a half. So 1/2 equals 1/2. So are those two lines parallel? Yeah. So yes, GH is parallel to FE. This is your explanation. All of that work is your explanation as to why. So is that one okay? We're kind of going in the reverse order. And last but not least, this diagram. This time we have 3 parallel lines, and we want to find x and y. Why would those two have to be equal to each other? Not just because they're both x's. Well, what can you tell me about this diagram? Look on the right-hand side with your y's. What can you tell me about those two? What type of marks do we have here? These are congruent. So if we were to write a ratio or a proportion, these two would end up being the same thing, right? Because they're congruent to each other. So, I don't know, let's pick a number. These end up being the same exact thing. Let's say they both end up being 15. I don't know what they end up being right now, but let's say they both end up being 15. What does that tell you about your two values over here? Do those also have to have the same number in the end? Yeah. So because of these two congruent marks, we can start off by saying 5/3 y plus 1 should equal 3y. And we can solve for our y. Because those two are congruent to each other, when we set the proportion up, it's going to mean that these two also are going to have to be equal to each other. So our second equation would be 3x minus 4 is equal to 6 minus 2x. And so now we just need to solve these both. So the top equation, 5/3 y plus 1 is equal to 3y. How do we solve that? What would we do first?
Couldn't you add 5/3 y to 3y?
Not add 5/3 y, subtract 5/3 y, yep. Okay, so then we have 1 equals, what's 3 minus 5/3? How could we write 3 as a fraction over 3? Put it over 1, and then we could get the same denominator by multiplying top and bottom by 3. So it would be 9/3 minus 5/3. What's 9/3 minus 5/3? 4/3 y. How do you get your y alone then?
Minus 4/3.
Not minus 4/3. This is attached with multiplication. We divide by 4/3, which is the same as multiplying by 3/4. So what's our value for y here? Times 3/4.
1 3/4.
3/4. If you're terrible at fractions, I suggest you use a calculator.
I'm a phone. I can pull it out.
Okay, so because over there we knew that those two had to be equal, when we set up the proportions, the other two sides then also have to be equal, so that's where we get our second equation from. So 3x minus 4 is equal to 6 minus 2x. How would we solve this?
Well, you take plus 2.
Okay, so I'll add the 2x.
What you get 5x?
5x, what should we do with this minus 4? Add it to the other side. So we get 5x should equal 10. So then x is 2. Okay? So that's what, it's just setting up more proportions. It's just the diagrams are going to look a little bit different.